At the conference this year, I'm talking about melanoma risk phenotypes and how the genes that underlie the predisposition to these particular phenotypes are modified by ultraviolet radiation exposure and how they work together to alter or modulate a person's susceptibility to melanoma. So they clearly have a major effect working together. So ultraviolet light really does impact on melanoma in a very big way. It's actually the main carcinogen that really drives melanoma development. But the underlying person's genetic makeup is very, very important also in how they actually respond to that ultraviolet light. And that could either be ultraviolet light from sunlight, which is the way that most people would get it, but also it does impact on people that still use tanning beds and get artificial ultraviolet radiation through that particular source. There are genes that really play a major effect in melanoma predisposition, and it turns out that these, the main players, if you like, these genes also impact on features of an individual that you can measurably measure. So these include things that are quite obvious, like pigmentation differences. So we'd be all aware that people that have lighter colored skin, people that have red hair, lots of freckles, lots of moles or melanocytic nevi, those individuals are all at quite high risk of developing melanoma. But there are genes that actually control the development of nevi or freckles, or basically set a person's constitutional pigmentation makeup. So if we can find the genes for those particular traits, and it's often easier to find genes for these what we call endophenotypes, so they're actually a phenotype that's associated with the one that we really want to measure, then we can, once we found those genes, we can then test specifically for whether or not those genes are then also involved in the predisposition to the particular disease that we're looking at. So a lot of the initial studies for melanoma were actually done by mapping genes for variation in pigmentation and also variation in the total number of moles or nevi that people developed over their lifespan. And to date, all of the genes that have been shown to be involved in pigmentation or nevus development have in turn been shown to be predisposition genes for melanoma. And then there is a third, I guess, category or phenotype of genes that has recently been shown to be associated with melanoma risk. And these are genes that are involved in the regulation of telomeres, which are the repeat pieces of DNA at the end of each chromosome. And it turns out that everyone has their own particular ability to maintain telomeres at a particular length or not. And it turns out that because the telomere length variation in individuals is so genetically controlled, that this impacts that person's susceptibility to cancer types. And melanoma is one of the cancer types that's most strongly associated with the length of telomeres. It's a difficult area in that a lot of these genes that confer risk in the general population have a very small or modest effect size, so that the individual gene might only change the risk by between, say, 10 and let's say 50% on average. So you could say that that small increase in the amount of risk conferred by a particular gene is not clinically actionable. So you could measure it in a pre-symptomatic setting, if you like, but you would be hard pushed to decide to actually do something about that for a given individual that came into a hospital wanting a particular diagnosis. I think in terms of the interaction between ultraviolet radiation and genes that confer melanoma risk, the main ones I think that might be actionable in some sense are the genes that are involved in pigmentation, because you can change a person's pigmentation using small molecule drugs or chemicals to actually give those people a tan. You can make pigment form, and that might be a preventative strategy, if you like, for increasing a person's photoprotection from solar radiation by increasing their skin coloring. There is a downside to that, because increasing melanin content, the pigment in the skin, also has a number of sort of detrimental effects, and the jury is still out as to whether or not it's totally safe to actually use chemically induced tanning as a mechanism of sun protection, rather than blocking out the harmful rays of sunlight, which is what most sunscreens are attempting to do. So I think in terms of behaviour, the message from the cancer funds is still the one that resonates the strongest, and that is the message of slip, slop and slap. You've got to cover up, you've got to use sunscreens, you've got to avoid the sun in the middle of the day, and seek shade. These things aren't going to change, and I think that the message in terms of prevention is still very much around avoiding excessive sunlight exposure.